Hello, we're going to take a look at some rational functions, and I put together here some guided notes to help you through some more information as we go through our section 2.6 in our pre-calc class. Okay, so let's consider the graph of a rational function, where our rational function is something like, remember, it's a fraction made out of polynomials. So I've already put on here, it'd be like taking an f of x poly over a g of x poly. And then I just sort of wrote it out over here in its generic form, if you will. Okay, so then some things we have to consider when we analyze our functions. Okay, we want to know about end behavior, and I put in here our rules about HAs. Okay, so what's happening at the end of those functions? If the degree on top is smaller than the degree on the bottom, you know that y is going to be 0 for your HA. If the degrees are the same, it's when you take the leading coefficient over the leading coefficient. So maybe it looks like a sub n over b sub m is what you end up for your HA. And the third case is if the top degree is greater than the bottom, then you just simply have no HA, and you may have something else. You may have a slant asymptote or something else going on. Okay, your vertical asymptotes, your VAs, occur at the zeros of the denominators. Okay, so those are the places where x cannot exist. X-intercepts are your zeros, or if you look at your numerator, you can find those zeros pretty quick. You just have to make sure it's not something that would cancel out with your denominator. Okay, and finally, y-intercepts occur at f of 0. So in other words, I'm just saying let x equal 0, see what you get, then you're on the y-axis. Okay, so let's take a look at an example here. So I'm to this part here where it says, what if you have no HA? In other words, the degree on top is greater than the degree on the bottom. Okay, for example, f of x equals x to the third over x squared minus 9. Okay, and I guess I was supposed to write that there. I got over to the side a little bit. Okay, so you see that your degree on the top, x to the third, okay, so maybe I'll make a note here. Degree n is greater than m, okay, so x to the third is bigger than x to the second if you're looking top to bottom. Okay, so when you reduce that, you end up with x. That's going to end up looking like the end behavior model for our particular function. It is not horizontal. Okay, in fact, we could take a look at this and say, well, what if I took x to the third and actually did long division by the x squared minus 9? What would that look like? Okay, we could put in here a placeholder. We'd have in here an x, so that we'd have x to the third minus 9x. Draw your line, change your signs. 9x is your remainder. Okay, so we end up here with x plus 9x over x squared minus 9. Well, this part right here is what we will call a slant asymptote. Okay, in fact, if you think about the graph, or put this function in your calculator and take a look, that slant asymptote would be y equals x, which is just your line coming through here like so. All right, and then if we look at this function a little further, since I started the graph, over here at x equals 3 and x equals negative 3, we'll have your two vertical asymptotes. Okay, and I guess I'm getting ahead of myself here, but the vertical asymptotes are going to be x equals plus or minus 3. Okay, and then that's again because x can't be 3 in that denominator, it'd be undefined. All right, while we're at it here, what about x-intercepts? Okay, an x-intercept. Well, if you look at the top of this, or your numerator of your function, so I'm looking here, okay, we could say that x to the third equals 0. So if that's the case, that means that x equals 0 is your x-intercept. And if you plug that in, you're going to have an x-intercept at 0, 0. Okay, so we're in here at 0, 0. So we're right on that asymptote line. While we're at it, let's go ahead and let's grab our y-intercept. So that means you're going to let x be 0. So f of 0, well, this isn't real exciting here. You're going to have 0 over -9, which again is going to give us the ordered pair 0, 0. So we have a y-intercept at that same blue dot. So if we kind of look at what we sketched versus maybe what you might look at on your calculator, you're actually going to find a little tiny section of graph down here, a little tiny section of graph up here, and then in between we're going to ignore that diagonal line, the y equal x line, and we're actually going to see, oops, there, sorry there, that just didn't want to work just right. Let's try that again. You know, you always an adventure here. All right, so put that back. So we end up here with a graph. It kind of goes like so. In between there. All right, so we could even go so far as to talk about the end behavior asymptotes. So let's start with this one. Let's say we take a look at the limit as x goes to -infinity for your function. So as you're coming out here to the left, left, -infinity, what is your graph doing? Well, it looks to me like it is going to -infinity. Okay, so what about the limit as x goes to positive infinity? So out here to positive infinity. So to the right, well, it's going up. Okay, up in here, up, up. So we have infinity. Let's verify your vertical asymptotes. So let's do limit as x goes to 3, or well, let's do -3 first. -3 from the left. So as you're coming in to -3 from the left, your graph is going down to -infinity. The limit x goes to -3 from the right. So coming in this direction, your graph is going up here to infinity. All right, test the other vertical asymptote, x equals, or x approaches +3 from the left. So if I'm going from the left here, coming into this asymptote line, we are going down to -infinity. And then finally, the limit as x goes to 3 from the right. So I'm coming this direction, and my graph is up high, going off to infinity. Okay, so that's a whole lot of stuff going on there with that analyzing. Okay, let's take a look at another example. All right, for this one, let's do f of x equals x minus 1 all over x squared minus x minus 6. Okay, so the first thing I would do is go ahead and factor that, or at least check and see if the bottom factors. Okay, so x minus, 1 all over, I would say that's x minus 3 and an x plus 2. Okay, so then you can take a look here, your x-intercept, for example. You would take x minus 1 equal to 0, so that tells you that x is 1, so we have a 1, 0 for an x-intercept. Y-intercept, do f of 0, so we're plugging a 0 in there, and that comes out -1 over -3 times 2, so 1/6. So y-intercept 0, 1/6. Vertical asymptotes, so look at your denominator for VAs. I see there an x equals 3 or x equals -2. HA, the n is less than m, so that's an automatic y equals 0 for an HA. So let's see, what does that graph even look like then? Well, looks like I've got some repetition down here. So I'm going to go ahead and I'm going to sketch this picture down here. So we have verticals at 3 and -2. Horizontal asymptote is just the x-axis. I'm trying to draw it so you can kind of see it on there. Then we have at, what is it, 0 and 1/6. We have, so kind of like right there, just above that x-axis, that's like 1/6. Okay, and then if you take a look at your calculator, you might be able to get a sketch of this guy. You've got a graph here, going over here, and again, bear with my sketching here. So we've got a graph looking like that. Okay, so then if you talk about the domain for this one, you're going to be from -infinity to -2, from -2 to 3, and then from 3 to infinity. So again, that's your x's. You're going from left to right. So out here is -infinity, +infinity. Okay, range. So we're going to go from bottom to top. It looks like everything's covered there. So -infinity to infinity. Are we continuous? I would say yes. And I would answer this one on the domain. So we're continuous in the little sections. Symmetry, no symmetry. Increasing, this graph's not going up anywhere, so I would say not. Decreasing, the whole graph, so that'll be the same as your domain. And lastly, do we have an extrema, min, or a max point? And we do not. Okay, and then I repeated HAVA and I got rid of those. Okay, so that's a nice analysis of a rational function graph. Okay, so I did put in here one more. If you have the time to hang in here and watch with me one more time. This f of x I picked is 2x squared minus 2 all over x squared minus 4. Okay, so like in the previous example, first thing I would do is factor. Okay, so I have a 2 I could take out of the top, x squared minus 1, and on the bottom, x squared minus 4. Well, really, we have difference of squares on both of those. So like 2, x plus 1, x minus 1, all over x plus 2, x minus 2. All right, so then we can go about our business here thinking about x-intercepts. So x-intercept, like we did up here at the top, if you set the numerator, like here, numerator is equal to 0. All right, so that 2, x plus 1, x minus 1 equals 0. You will find your two intercepts. So x is either plus or minus 1. So you could just say 1, 0, -1, 0. For y-intercept, you want to do f of 0. All right, so over here, f of 0. So if I plug a 0 in there, I'm going to get -2 over -4, or +1/2. So at 0, I'm at 1/2. Okay, VAs, look at your denominator. So you're going to have x equals plus or minus 2. Okay, so I'm getting that from looking right there in the denominator. HA, consider the degree. So this one, n equals m. So you're going to put 2x squared over x squared. That reduces to 2. So y equals 2. We're going to have an HA. Okay, so let's see if we can get a quick sketch of this, what we know so far. So our asymptotes at -2 and 2 for vertical. Do that a little crooked, didn't I? And then y equals 2 is going to be an HA. Kind of running into things here. All right, we have, let's see, y-intercept at 0, 1/2. and write that in so you can see. We have x-intercepts in this one at plus minus 1. Okay, so there's some special points in there. So if you sketch this guy, let's make this one green or something. All right, so up here, we have a little piece of graph. Over here is a piece of our graph. And then down here in between, and again, my scale's not the greatest, but you end up with a parabola looking item here in the middle. Okay? All right, so then what's that mean for the rest of our information? Well, your domain, if you're going from negative infinity to positive infinity, we're going to have from negative infinity to negative 2. Okay, jump over the asymptote, negative 2 to 2, and then on out 2 to infinity. Range, so from negative infinity up, we're going to be from negative infinity to 1/2, and then from 2 to infinity. So we go from the 1/2 all the way up to here on the range. Is it continuous? And again, I would say yes on the domain. Is there symmetry? And I think you've got symmetry on this one. This one I would say yes with respect to the y-axis. Okay, extrema, yes. It looks to me like you have a max at 0, 1/2. Okay, so that's that little point in there. Are we increasing? I see increasing from negative infinity to negative 2, and also from negative 2 to 0. Decreasing, are we going downhill? So it looks from 0 down here, so 0 over to 2, and then again from 2 out to infinity. Okay, and I think I've got all that in there. Okay, and then the last thing, we should probably hit the limit statements. Okay, so the limit, let's do the end behaviors first. So go to the left. As you're going to the left, what's your graph doing? Coming down here and approaching this asymptote, which is at 2. The end behavior as you are going to positive infinity, so as you're coming out here to positive infinity, again, you are approaching this horizontal asymptote, which if you think of your rules, that's what should happen. As you go on the ends, we should approach the HA. All right, then let's go the other way. As we're approaching negative 2 from the left, so as we're approaching this way, our graph is going to infinity. As we're approaching negative 2 from the right, we are going to negative infinity. All right, 2 more. The limit as x goes to 2 from the left, 2 from the left, we're coming down, so negative infinity. And finally, the limit as x goes to positive 2 from the right, positive 2 from the right, our graph is going up here to infinity, which and all those statements verify the HAs and the VAs are correct. And guess what? You've survived. I hope you can read my writing on the notes and at least the ideas of what's happening here. So congratulations. All done. Thanks for watching.